In previous classes, we have discussed about array list and linked list and vector. So what are the difference between these three that we are going to discuss in this class. So hope we aware of what is array list. It is a class, and what is linked list. It is a class which implements the list interface, as well as a vector. It is a class which implements the list interface. So these are the things that we have discussed, and all the free defined methods that was present with all the free defined classes as same and working and giving the same outputs right now. So what is the difference between these three? Very important. What is the difference between array list and linked list and vector? So this is very important. Array list and linked list and vector. So now we will try to understand the difference between array list and linked list and vector. So what array list will do, what linked list will do, what vector will do, when to use which data structure, that is important. So as I discussed, one thing we have discussed actually, array list is index based, right? Array list is index based. This is the one that we have discussed. Array list is index based. Very key point it is. So let me come back to this method now. What is the method name? That is get method. If you see, array list is index based, and this get method requires index as an input parameter, and it will return the value. So here one thing we have to observe is, if I wanted to retrieve the elements, means fetching the elements. When I wanted to fetching the elements from the array list, it will be easy. Why? Because array list is index based, and to retrieve the elements, we are using the get method. This get method also requires input as index. So what will happen is, if I wanted to retrieve the elements frequently, then I should use the array list. The reason, because we have the array list which is index based, and get method is there. If you pass the index, it will return the value. Now my question is, sir, linked list also having the get method, it will also return the elements only, right? It will also fetch the elements. Why I cannot use the linked list? That is the question now. To understand that, let me explain one more thing. As I told, linked list internally implement doubly linked list, and it is node based. Very important point, it is node based. So what will happen if I wanted to fetch the element? It is having the method called that is get method, and what you are passing, index you are passing. But what will happen? Linked list does not have the indexes. What linked list having? Basically, it is having the nodes. So now what will happen? First, what is the index that you are passing to get method? That needs to be converted into node. Needs to be converted into node. Sorry, needs index that needs to be converted into node, and that has to be written back, right? So it will take some extra time. So when we wanted to get the better performance for frequent fetching operations or retrieval operations, we should go for array list. The reason, because array list is index based, and whatever the predefined parameters that required for a get method, that is also index. So that is the reason we should go for array list when we wanted to do the frequent fetching or get operations. Where linked list is node based, actually here also we have the get method, but it will also give the element. But first what is happening internally, there is some more code they are writing, converting the indexes to node and returning back that indexes to the node. Clear? Next, very important point. I wanted to delete some element. So which one is the best option? So your functionality or your client requirement is each and every time you are deleting the elements from the array list. Then which is the best option? For frequent delete options, which one is the best options? Let me do one thing. Is there? Okay, so let me go with the PowerPoint. So what will be the difference that you will understand now? God, very bad. Go with word. To make you clear, very clear, that's what I'm trying to write and display it. Okay. Consider this is one of the array list. Right here you have some element. Okay, here you have some element, here you have some element, and you have some element. So from where index elements will be starting? Basically in the array list we will have the index 0 and right 0 and 1 and 2 and 3 and 4. Total 4 indexes: 0, 1, 2, 3, 4, 5. So we have total 5 indexes. So now what I'm doing is I wanted to remove this element. So index 2 having some element and I wanted to remove that element. So now what will happen? Let me remove this. So what needs to be done? If I have the 100 element in the array list, all the elements after deleted, whatever the elements deleted, whatever the elements present after that element, everything will change their indexes. So the third element index will be changing into 2, and fourth element index will be changing into 3, and fifth element index will be changing into 4. So there will be huge impact. So what will happen if I wanted to perform the delete operations with this one array list? It will be huge impact. Huge impact on indexing of the elements. Now we'll try to see how the linked list is implemented and what is the benefit that we will get if we wanted to use the linked list rather than using the array list, right? So let me do some same diagram like this. So how it will be implemented, let me show you first. Okay, so we will have the nodes, each and element, every element having the nodes actually. So how it will be implemented, let me show you what is nodes and how the nodes will be implemented, right? Okay, so this is my example. We have the 5 elements. Now you can see what will happen. How the insertion will happen, let me explain. So first I wanted to draw a diagram. Okay, so next we'll start and we'll see what is the benefit that we'll get. Okay, so this is the linked list. Basically what I told you actually, so here linked list having the nodes. Each and element will have the 2 nodes actually. Reference of the first element means immediate element. Whatever the element it is there, immediate element will be one reference and next element. First and next element. Okay, so now if I wanted to delete some element, so what will be the impact here? So I wanted to delete the element. This is the element that I wanted to delete it. So now what will happen, you will see. Okay, so here I wanted to delete this element and you can see what will happen. So if I delete this element, so there will be no impact actually. The reason because impact will be there, but very less impact. I will tell you how. Okay, here every element having their nodes and the reference for the element is previous element and next element, or first element and next element, right? So what will happen is if I delete this, okay, if I delete this, only impact will be this first position element. Let's suppose this is A and let's suppose it is B, let's suppose it is C. Likewise there is multiple elements. Let's suppose that is D, let's suppose that is E. Okay, if I delete the element of B, so what will be the impact actually? the A reference will be changed and the C reference will be changed. So here, this will pointing out to this as well as this one pointing out to A element. But remaining elements, whatever the elements is there, those elements references will not change. They are still same. So all the elements after the deletion, no need to change their reference, right? If it is an array list, if you are deleting the element of B, C position, D position, E position, F position, all the element positions are changing. Where in linked list, if you wanted to delete an element, there will be very less work or less change that is happening on background, right? There is no much changes. You no need to, or there are no need to, there are no need to changing this value, means these references. So C indexes is changing, previous index is changing to A, and A next reference is changing into C instead of B. That's it. This is how the nodes will work. So what I will tell you from this concept is, since it is a double linked list and having the nodes, when you wanted to delete frequently from linked list or any of the list class, that is array list or linked list, recommended to go with the linked list. The reason, because performance wise it will give the better performance, because there will be no background operations happens, because there will be very less impact. When you wanted to do the frequent fetching operations, which one is recommended? You have to go with the array list and linked list. When you wanted to do the frequent updates also, you should go with the array list, because you know the index, just you find the index and you can update in the same place. Okay, frequent updates and frequent retrievals, you should go with the array list. Frequent deletes, you should go with the linked list. I have explained how that will happen on backgrounds. Right now, array list and vector. So vector also internally uses the array data structures as like array list. And here, as I told, vector is synchronized one, where array list and linked list are not synchronized and vector is synchronized one. When I say synchronized, what will happen? Synchronization is a mechanism will allow one process at a time. Multiple programs are trying to access it, so that it will not allow actually. So it will allow only one process at a time. That is called synchronized. So when you're performing add operation and you're performing update operations, you're performing delete operations on the same collection object. So it will be allowing only single operation at a time. Multiple operations cannot be performed actually. So that is how the synchronization is implemented. Synchronized keyword is the keyword that we will use to achieve the synchronization. This is very important point. And the second important point is, vector is having the memory size. Like what will happen is, when you declare a linked list or array list, there will be some space, specific size was fixed for array list and linked list, whereas vector also having some specific size. When it comes to vector, what is the benefit that we are getting? Let me tell you. So what will happen with array list and linked list? See, initially you started with adding the 10 elements. Again, there is a change, you wanted to insert 20 elements. Again, there is a change, you have to insert the 40 elements. So what will happen in array list and linked list? So initial size will be there, right? So once the initial size will be filling, they're giving the 50%. Again, that 50% is filling, then they're giving the 50% extra memory. So each and every time that size is fixed, then they will extend the 50% of memory, where linked list also having the same formula. 50% of memory allocation will happen for array list and linked list. So now what will happen if you wanted to change or add the elements frequently, multiple times? So first initially you thought 10 and next 20, next 40. So what will happen? Each time 50% again that will be filled. Again they will extend the 50. Again that is filled. And next they will again extend the 50%. Again that is filled. So it is not recommended when you have the frequent insets. The reason because extending their memory from the standard size to new extension, 50% of memory allocation will happen. Where for a vector, there will be 100% of memory extension. Means initially, if they are giving or allowing, suppose I'm telling, so they are allowing 20 elements. If the 20 elements is filled, actually, you can insert 40. Once the extension is happen, right? Again, you can insert 20 more elements. Where in linked list and vector list, what will happen? Initial size 20. If suppose initial size is 20, if that is filled, what will happen? 50% means 20 plus 50% means 10. Then you can insert the 30. Again, if it is filled, what will be the size? 30 plus 50%, 50, 45. And again it is filled. So this is how this formula will goes. Where vector initial element is 20, if it is filled, what will be the percentage here? 120 plus 20. Here you will get 40 elements. You can insert it. If the 10 again that is filled, 40 plus 40. So that is 80. And if it is filled 80, then 80 plus 80. So this is how it will go. So now you are clear with which class, list classes. These are array list and linked list and vector. These are the classes which implements the list. So based upon your requirement, you have to select the best class. So when you wanted to do the frequent searching operations, you should go with the array list. When you wanted to do the frequent delete operations, you should go with the linked list. When you wanted to do the frequent insertions, creations, you should go with the vector. And one more important point, as I told, for update also, if I wanted to update again, I can give the index and I can update the elements. So here earlier value is Nagesh. If I wanted to update to Nihan, only if I need to find out the index of that element and I have to pass it. Where in linked list, it will be difficult because you are passing the index that needs to be converting the node and need to be set which value is that node having. Again, comparison background, there will be lengthy process. So this is the major difference between the three classes which is belongs to the list interface.